I'm glad that we could make this workout with um, Liz and David this week to talk about fossils um, and the uh, different things that they're going to talk about tonight. So I guess without any further ado, I guess we can just get started and talk about the uh, different sites in the in the state where fossils are really important, and in their talk about their new book, Spirit Whales and Sloth Tales: Fossils in Washington State. So I guess with that, I'll just let Liz and David get started and give their presentation. So thanks.
Thank you. It's a
Thank you.
pleasure to be here. Let me just do a share screen with everyone real quick and make it all big and pretty and great. Can everyone, the screen's up, it looks like I can see there. Great. Well, thank you for asking us to come. I mean, it was sort of last minute, which is fun for us to be able to share this story of the book that Liz and I wrote together. What we'd like to do is probably spend about 15 minutes, 20 minutes with us just chatting with each other, sort of a discussion about the book, you know, what it's about, where it came from, how we came about to doing it, maybe highlight a few aspects of it that we find intriguing in terms of sort of concepts. And then we will talk about some of the sections in the book. Liz will do one and I'll do two. And hopefully we will be done in about 40 minutes and then be able to open up for questions from you all. That I think is what is something we always try to do, because it's fun for us to learn what you're interested in and also to be able to share ideas and hear your thoughts, because we always learn from this, reaching out to people such as yourself. Liz, do you want to say anything before we chat?
No, I'm just really happy to be here on the east side of the Cascades without being there. It's a brilliant idea.
Great. Well, you know, this book, Spirit Whales and Sloth Tales, came out about 2 months ago. It was published in late October, and it was the product of about 4 years of work between Liz and myself. And as I've said at other talks before, this book to me really is Liz's book. It was her idea, it was her inspiration, and I was lucky enough to be able to join with her on the book. And I guess my first question, this one we always start with, is Liz, why, what, where, what's the story of this book? How did
Oh,
you?
it's a long story because I have been a paleontologist in Washington for 40 years now. And I've talked to a lot of people about Washington fossils. I've done a lot of field trips. I've seen a lot of fossils. I do my research here. And over all those years, people have always asked me, what more is there? What can I see? Where can I go? What have I got? Why is this important? And they always ask for more to read. We needed a book. There is no book on Washington fossils until we wrote this book. And so after many years, because I was busy, I decided we needed to write a book. So I started, and that was fun. And then when I had finished, and this was COVID time, you can all appreciate we were stuck at home trying to do things, I realized it was kind of boring. And I needed somebody who could bring life to the book, who could understand that we wanted to write a book for the general public. This is not a textbook. This is not a field guide. This is a book about stories, about fossils, about Washington. And so I asked David if he would join me, and he said yes, which was wonderful. And so he had to deal with what I'd already written, poor guy, and we went from there. But I have a question for David now. Why did he want to join me? Why did he say yes to this project?
Yeah, I mean, that's a good question. I mean, part of it, Liz, is, you know, I was lucky enough to have worked with you at the Burke Museum for many years. I was in education, and obviously you were working there as a paleontologist at the museum. And so I knew that your outlook on fossils and on education and on how to convey information was aligned with the way I try to do things. And so I knew from that point that there was a relationship that would work between the two of us. So that was not a big issue. And the second part is, as a writer, one of the things that always drives me and really centers my writing is trying to think about the connections between people and place. How do we influence landscape, and how does landscape influence us? And I've done this through a variety of book topics, mostly centered in Seattle, whether it was looking at things like the Denny regrade or taking people on leading a guide to walks around Seattle, to looking at building stone and how do people use stone, and what is that human and natural history story. So I had that interest in it from the beginning, of that connection to place, and fossils was just one way, another way to do it. I hadn't had a chance. I'd written about fossils in a variety of different places, but this was an opportunity really to get involved much more deeply. And one of the things that for me was fun, I was looking forward to, is not having to do the research. Usually when I write a book, I'm the person who's doing all the research, which I love doing. But this, I knew that I would be with or I would really call you the expert on Washington state fossils. And so I had that opportunity to learn from you, but also to, figure out ways that we could craft the stories together. And I think out of working with you and working with the press, we came up with this idea for the book that I think is pretty interesting. It was something that we came up together, but I'd sort of love to hear how you describe what this book is, Liz. You said it's not a field guide. It's not an academic book. It's not a scholar. It's not a classroom book. I mean, what is it? I mean, you said story. So what does that mean?
So it's stories, and this is the interesting part of working with you. It is stories about fossils, but it's also stories about the people who found the fossils or the people who worked with the fossils. And one thing we have really stressed in a number of different chapters is the amateur fossil hunters or amateur paleontologists writing papers, and what a huge influence they have had on the history of paleontology in this state. People don't think of Washington as a state full of fossils. We have little compared with other states, but what we have is so interesting. We have such a wide variety of interesting things. I mean, look at Montana, they have dinosaurs. That's all they have. That's not true, by the way. We have all sorts of different things from all sorts of different geological environments. And so we base the book a lot on what the geological environments are and how come these animals, plants, organisms were living in that environment. And that was the fun part.
And so how's it broken up? Or what do you I think one of the things was making it, I think, a little bit, trying to make it different than things that were out there. I like to think we took a different approach.
We did take a different approach. We first of all divided up into separate chapters, and each chapter discusses a fossil and its environment and the other fossils that are somewhat associated. So each chapter is a story about one particular area or one particular type of fossil or one particular age. And then we decided to do something different and start from the more modern, from the Quaternary, and go backwards in time. And I really wanted to do that because I know from all my many years of teaching at the university, you start with what's familiar, and then you take people back into what's less and less familiar, because it's hard. It's hard for us to think about things that we've not thought about before. And if you take it back in time, that's what we do. We were lucky. We have fabulous fossils to be able to do that. But one thing I want to ask you about, David, is we do have big time gaps, big geographic gaps in the book. So why did we have those gaps? Why did we just not have a nice flowing thing all the way through time?
I'm sure talking to a group like this, sort of preaching to the choir, if you will. I think most people recognize, certainly who do anything with geology, is that more of the picture is always missing than is present. No matter what landscape you look at, you're always missing a big chunk of the story. I mean, anything, even the Grand Canyon, you have a mile of rock, you're still missing vast periods of time. So Washington is no different than any other place in having missing periods of time. But the other aspect of Washington that I think makes it different, and we'll come back to this at the sort of the very end of the talk, is the idea of the jigsaw puzzle. That when you look at the state, the very oldest rock is in the northeast corner at 500 million plus years old. That's the sort of original rock over there, original part of the state. But everything to the west of that, much of it was sutured on or added to by plate tectonic action. So we just didn't get certain rocks here. So that's one problem, is that we don't have the time periods of the rocks because they may not have been deposited here. I mean, the state didn't even exist. The other aspect of it, and this is certainly something that I think about a lot, and I think many people do, is that, we really benefit in the state from our igneous rocks, whether it's the Columbia basalts, which, are certainly beloved by many, or the mountains, the Cascades, but the problem with the Cascades and the Columbia Plateau is that it's covered a lot of rock. So we maybe have stuff, but it's just missing. So, I mean, I think that's one of the challenges in the state. So it gave us such that the book in some sense is front end loaded, as you said, with things that people are familiar with, but it's also where some of the best fossils are in the state are the youngest ones, just because of the way preservation has worked and the geologic story. And I think that's another part of what we were trying to do, was to tell that geologic story too. We tell it sort of in two places in the book. We have an introductory section about geology, about fossils, how fossils form, plate tectonics. That's sort of intro to geology in a very quick manner. And then throughout the book, throughout all the sections that Liz mentioned, those each have geology in them. So it's definitely a key part of the story here. So I think that's how I interpret it. Would you add anything?
No, there are a couple of stories that didn't get into the book that we know there are fossils. But if it didn't make a coherent story, we didn't include it. And so there are areas like the Nooksack and the North Cascades that has really exciting fossils, but there's still a lot of research to be done. So we didn't have a story that made scientific sense for that one. Right now I'm working on some very young fossils from the coast. And again, we didn't include that because there's still work to be done. There's so much paleontological work to be done in Washington still, that there are stories that didn't get into the book.
And it seems like one of the real big ones that it actually made it in the book, but we're not going to talk about tonight, but I'd still maybe like to ask you a little bit about, the title of the book was chosen very specifically, Spirit Whales and Sloth Tales. We sort of like the how it sounded, but the spirit whales, and that seems to be, I know when I got involved in the project, I knew nothing about them. And that seems though that whales are arguably sort of some of the most important fossils we have in the book. And I know one of them is named for you. So I was hoping you could just tell us a little bit more.
Yeah, that was a great thrill to have a fossil named after me. So for the time period of about 25 to 35 million years ago, we have a lot of marine rocks that have been shoved up onto the coast so we can actually get to look at them. And that's really thanks to the Olympic mountains growing. And in those deeper marine rocks, there are fossil whales and dolphins and seals and a few other things. And there's been one particular collector, Jim Geddett, who has gone out, I think since he was 12 years old, and walked all the rivers and all the beaches and collects these amazing fossils, brings them to the Berg, and then he hopes that he works on them, but he hopes other people will work on them as well. He encouraged a graduate student called Carlos to come to the Berg and look at some of his stuff, and I could help him and the other paleontologists figure out the exact age of these fossils, because we always want to know what the age is. We're trying to figure out evolution. And because I'd spent time with it, they named the fossil after me. So it was a huge thrill. I can't tell you how thrilled I was about that. But I also just wanted to tell you, just the other day, I got a email from a paleontologist, a vertebrate paleontologist from Colorado, to say how much he enjoyed the chapters on the whales, because he didn't know anything about fossil whales. So it's not many people who know about fossil whales.
So how do you feel?
Washington's very lucky to have.
How do you feel as an invertebrate paleontologist to be have a vertebrate that you're named after? I guess you also have you've also an invertebrate on it.
I have a little snail. So I have this big whale and a tiny little snail. I will take anything. I don't care. It's very exciting. It's very fun.
But you've also made the point, I think, though, and the part of the reason I was asked about the whales is the idea that there's a lot more work to be done.
Yes. There's a huge amount of work to be done. And one of the issues with the whale fossils and the other vertebrates that are in these sort of latest Eocene and Oligocene rocks is the rocks are incredibly hard. They're all cemented. Preparation to get the bones out is very difficult. The bones are much softer than the rock, and you need a professional preparator. That's what you get in a museum, and it's a slow job. So a lot of material is there and needs to be prepped before anybody can work on it. And that's what slows everything down.
How long did the spirit whale take?
The spirit whale itself took 4 years. Now, it was Bruce Crowley was working on it, and he started actually on the floor of the old Burke Museum, but it wasn't his only job. He wasn't doing it full time for 4 years. He had many of other jobs going on at the same time. But it's an entire whale, which you can see from the picture there, which is also very unusual. Most of our whales, we just have the skulls, but this is the entire whale, and it's on display at the Burke Museum right now. You can go and see it. And the whale that was named after me is actually from Oregon, but it's on display in the Smithsonian.
Ah.
That's
cool. But we mention it, but it's Oregon, so we really
it's Oregon, yeah, but that's okay. Geologically, we're all the same.
Oh, now we're expanding out.
If you don't notice a river that goes between us.
Oh, right. It's only part of the state, Liz, only part of the state. So, I mean, again, I think part of that story of Jim and Carlos and you and the science is that so much has changed in the time you've been in the field. And I think that's something we really try to convey in the book. And it just, we're not going to go in depth on it, but I'd just love to, again, I always like to hear your story of how paleontology has changed in the time that you've been involved.
Enormously. It's changed enormously. And it's really the technology that has made the big difference. Radiometric dating is always one that we rely on, because most paleontologists want their fossil to be the oldest of whatever it is. They always want to be the oldest. And so we would like to have good radiometric dating, and the science that is associated with the technology of radiometric dating has just made giant steps since I started. There are many other things that are associated with that, and that's imaging. CAT scans, MRIs, a variety of what we might call invasive imaging that you can look through the rock and see what's in there. And that's been huge. The other thing that's very big that people don't really seem to understand is we now have very large databases of data about fossils. And you can do big data studies. You can look at fossils from all over the world, or you can look at fossils from all over North America, or you can look at fossils from all the Eocene around the world and come up with some really good ideas. And that's changed. It's all because of computers. I remember when I started at the University of Washington in 1993, email was just starting. And one of the first papers I wrote with a colleague in Southern California entirely through email. We never saw each other during that time. Things have changed completely. Now we have Zoom, and we can talk to a whole bunch of wonderful people on Zoom. So, David, I have a question that follows on from that, and I want to know what What surprised you about this? What surprised you about the stories that we came up with that you hadn't really thought about before as a geologist and a non-paleontologist?
Yeah, I mean, I think part of it is the integration of the science. Growing up, and I had a degree in geology, but even back when I got my degree, which was now 35 years ago, paleontology was seemingly just changing from being a science that was primarily focused on names and describing all the species. And it seems like over the last many years, and I know you've made this point when you and I have been chatting, Liz, that it's gone from a field of description of just the names to now a field that is integrative, that you work with physicists and mathematicians and ecologists and all sorts of different people who are really helping to bring paleontology to life and bring the fossils to life. And I think I was struck by you saying that when you first started out that you'd write a paper and it might be you and one other person. Now you write a paper and there's 20 people involved because you're bringing in so many different disciplines.
Yeah.
And for me, that was, I mean, I sort of knew that, having written about geology for many years, but to really see it in all sorts of things, not just in the sort of big animals that we make it in the news, but in the smaller ones. I mean, the fact that, again, going back to the whale, able to understand that better because of the snails and such that were associated with the whale skeleton. I thought that was just amazing that you're again bringing in different disciplines to tell a much fuller picture. And in doing that, I think it helps us understand. Again, it gets back to my interest of connections, and that you see one of these animals, or we hope that when you read the stories, that each of these profiles, that you come away with this sort of deeper respect and deeper understanding of this place here. I mean, Washington is an amazing state, geologically, paleontologically. So we were always trying to convey that.
Yeah, that's true. I mean, life really has changed, and it's much more collaborative, and that makes it much more fun. It really makes it much more fun.
So,
and we also have museums full of stuff now. So we've worked hard in the museums to accumulate fossils and have them available for anybody to use. The Burke Museum is the Washington State Natural History Museum, and it belongs to the people of Washington. And anybody in the world can borrow fossils and work on them. And that really helps to get paleontology moving. And I also want to mention to everybody that David does a newsletter every week. And often in his newsletters, it's this idea of working with a lot of different people to come up with a story of the natural world. So you want to say something about your...
I'm going to hold off on the newsletter for a bit. I appreciate that.
But it's so much fun. But it's so much fun.
I'd like to do I think would love to hear you. I think that's actually a good, I was just about to segue to having you talk about this one image in the book, if I may. And you're going to have to, since I have control over the arrow, you're just going to have to tell me.
Okay.
When to go forward. So the cover image had a sloth on it, and this is an image from the inside, and these are images that are from the exhibit at the Burke Museum, but we put them into the book because we really wanted a beautiful book. And this is really a story about the Ice Age megafauna. Now, you guys in Wenatchee know all about the Ice Age, and I do have a couple of maps just for the people who don't know. But megafauna means very large animals, larger than 100 pounds. And they are mammoths and mastodons, bison, the sloth, and they lived in Washington, have been preserved in the more recent sediments left over from the last Ice Age. And one of the things we look at when we think about it, we had a professional paleo artist draw this, and I thought, how do we know? How do we know what this looked like? So next slide. So first of all, you have to think about what the environment looked like at the time.
So in the last ice age, and we're talking about the very end of the last ice age, the whole of the northern hemisphere was covered by ice. And you can see we have different sections of ice here. And the dark green one is the Cordilleran section in our area. And Greenland, Iceland, all of Northern Europe, all of Siberia were covered in ice. And this was the greatest extent of the ice. Over the time of the Quaternary, 2 million years, the ice expanded and retreated. But note here also that in Alaska, there is no ice. It was a desert. There was no precipitation. It was a very cold desert, but it was a desert. And you can see that across, with its connection with Asia, it was also a desert. Sea levels were exceptionally low because so much water was taken up by the ice. Sea levels are 300 feet lower than they are today, which means there was a land corridor between Asia and Alaska, and the animals could walk up and down. In the times when the ice dissipated, the animals could walk all the way down to below where the ice is. Next slide. So this is what it looks like in Washington State, and you guys are all super familiar with this. And it came right down Puget Sound all the way down to Olympia. And the two red arrows are just to remind people that the mountains were also covered in ice. These pictures always show the ice sheets, but they don't show the fact that, in fact, the Cascades and the Olympics all the way down were covered in ice too. So the animals lived south of the ice. As the ice expanded, they all moved south. As the ice retreated, they all moved back. And these areas got invaded again by land, by plants. And it is the very end of the Ice Age that we have most of our fossils of mammoths and mastodons. Next one. Next one. All right. So here we have our very large elephants. They're all proboscideans, which means they have long trunks. And the next one, just press it one more time. Thank you. The biggest one is the mammoth. The in-between one is an African elephant, a living African elephant. The smaller one is a mastodon. So the mammoths we have are, the adults are up to 14 feet high, so they are very large. And we have the Columbia mammoth. The mastodon is the American mastodon, and it's the same all the way through. So next one. So here is a picture of our Columbia mammoth. We do not have woolly mammoths in Washington State. There are woolly mammoths in the eastern US, there are woolly mammoths in Canada, but here we have the Columbia mammoth. And one of the new exciting things about paleontology is some very clever people in Norway have been getting DNA from the carcasses of mammoths that were preserved in the ice in Siberia. And they have found that there are actually 3 mammoth species. There's probably more, but 3 mammoth species, and they seem to have interbred. So by looking at the bones, we can say, all right, this is a Columbian mammoth. But if you get DNA, it makes it a little more complicated. Anyway, so here's our Columbian mammoth, very big, 10 tons, very high head. You can see a big domed head, very big jaw. The head has muscles to hold those gigantic tusks and muscles to hold the head onto the backbone. Long, straight legs. They are herbivores. They're all herbivores. They walk on their tippy toes like ballerinas, but of course, like elephants, they had big, fleshy pads, and they ate grass. Next slide. So here is the jaw. So for almost all mammals, we go by the teeth. The teeth tell us what these guys ate, and they tell us, therefore, how they lived. The mammoth jaw is very large because it holds very large teeth. And this is the molar. In the mammoth jaws, they have 1 molar in each jaw at a time. So like us, there are 6 molars, but each one set is all by itself at any one time. When the top wears off, it drops out and a new one comes in. They are designed to eat grass and anything with silica in, and so they wear down pretty quickly. The tusks, I forgot to tell you, the tusks are the incisors. They're not the canines, they're the incisors. So let's compare this to a mastodon. Next one, that's a mastodon. Although on the outside they look the same, they're much smaller, but the teeth are completely different. They too have one or two molars in their jaw at any one time, but these are designed to eat a much broader range of food, leaves, twigs, those sort of things, very similar to pig's teeth right now. Okay, next one. So that's how we can decide how these guys lived. We know what bison ate because they're still alive, and we can reconstruct the environment based on what the animals did and how they lived. But we have one more tool. Next one, David, please, is pollen. Pollen has been an enormous help. Pollen is incredibly well preserved. It is very abundant. And the way to collect it is to collect a core. And so here we have the University of Washington, Carrie Garrison Laney taking a core in an estuary, but you can take cores in lakes, and cores have been taken in all the lakes in Washington to look for fossil pollen. And then once you have the core, you can make samples all the way through the core as you go up and look at the changes in the types of pollen. And so you can see how everything started with tundra, and then we got grasses, and then we got bushes, and then we got trees as we went through time. We're also lucky in Washington, as you all know, we have volcanoes. And so the ashes in each of these cores can be dated, or we have ashes like Mount Mazama that you can recognize straight away. And that gives us a lot of information on the environment in which we were looking at the time. Thank you.
All right, my turn. Thank you, Liz. So I get to focus on probably the most unusual fossil in Washington state. I'm guessing probably many of you know about the Blue Lake rhino, but the story goes is that, and this one reason Liz and I both like this story is it's just so connected again to people. In 1935, there were two couples from Seattle were out exploring this area in eastern Washington. They were up near the Blue Lake, and they had hiked up this canyon, up Jasper Canyon, and they came across a curious looking cave in the basalt. There was this opening in the basalt, and I'll show you that in a second. My guess is probably some of you have been there. And they found the cave, and it was odd in a variety of senses. In particular, one, it was very smooth on the bottom, which is unusual in a cave in basalt. The other aspect is that within that cave was a jawbone. And they didn't really know what they had. They knew they had found some sort of animal. I think we thought it was probably some sort of fossil, but they weren't sure. So they ended up bringing that fossil back over to the University of Washington, and they took it to the geology department. They didn't have a paleontologist, so they actually shipped it back over to Ellensburg to a paleontologist there, and he, looking at the teeth, or the bone right here, the jaw, and then eventually going out to the cave, figured out that it was some sort of rhinoceros. He really had no idea what type of rhinoceros it was. Interestingly enough, that fossil and the cave, a variety of people went to it, looked at the fossil, and over time, it keeps changing, kept changing, and it's now this particular beast. This was an animal that was pretty widespread in the Midwest. So this rhinoceros was out there. It was smaller than our modern rhinoceros. But in putting together the story of it based on the teeth, looking at the cave, and again, thinking about the geology, what they think happened with this rhinoceros is it was about 15.8 million years ago or so. The rhinoceros was wandering around this environment, the sort of the big open habitat of the Columbia Plateau area. It dies. This sadly dies, starts to bloat as dead things do, and it ends up floating in a lake. some sort of lake in this environment. And then, because, as again, you probably well know, lots of lava in that part of the world, the lava comes in, and when that lava hits the lake, it cools, and it cools and forms a cast around the rhinoceros. So it was upside down, legs sticking up. So if you've been in that cave, I've only read, I've not seen. The cave's about 90 inches long, and at either end there are these sort of little holes poking up into the ceiling, and those are the legs of that rhinoceros. This is the entrance to it. Sadly, it's apparently is well marked as something to find, which is always an issue. We do not actually in the book mention any specific locations for fossils, in part just because we're concerned about, majorly because we're concerned about, but also in many cases they're not in any place that one can get to now. They're on private land, or the Burke or someone had a special permission to get there. But they've subsequently figured out, as I said, about 15.8 million years ago. And we like about the story, I mean, I'm speaking for both of us, I think, from having worked with Liz, is again, it's people going out, paying attention, noticing something, collecting it, which is, that's, maybe they should, maybe they shouldn't, but back in the 1930s, certainly different era. But they collected it, brought it back to someone who could identify it, and then over time, through a variety of ways, they were able to piece together what is really sort of an amazing story about this. And it's singular. There's nothing else like this cave, rhino cave, anywhere in the world. It's definitely, I said, our most unusual fossil. Perhaps one of our more sort of kind of famous ones, even though Liz is not too happy about it, is the dinosaur that was found on Susha Island. Earlier on, I talked about the idea of Washington State being this jigsaw puzzle of rocks that were sutured on by plate tectonic action. Susha Island really illustrates that very well. And in fact, the entire San Juans are this sort of micro jigsaw puzzle. So if you go to Susha, the north end of Susha Island is sediments from about 55 million years ago. So fairly recent sediments. If you've been there, you've probably seen the beautiful erosional forms. But on the south end of the island, what you see instead, zooming in a little bit, and Fossil Bay, is marine sediments dating back to about 85 million years ago. So these two pieces have come together and come to form the island. Well, probably the most famous fossils, or best known, for at least in the paleontological world, fossils on Susha were the ammonites, which gave, I think, the name Fossil Bay to this area. But the story goes is that in 2012, two geologists, David Starr and the person Liz mentioned earlier, Jim Geddert, were out there collecting ammonites. They had a permit to do it. They were studying it. And they were out there at low tide, and they noticed a curious rock in the sediment there, in this marine sediment of the Susha Island rocks. And Geddert and Starr recognized that it was looked like some sort of bone from some sort of vertebrate, either a dinosaur or maybe a marine reptile. As I'm guessing many of you are aware, dinosaurs and marine reptiles are two different groups. Dinosaurs were strictly terrestrial or land-based, and then the marine reptiles. But what happens is they get the information, they come back to the Burke Museum, and they tell the Burke people there that there's this interesting bone. They think maybe dinosaur, maybe not. So a team goes out, including this gentleman right here, Brandon. They go out at low tide because that's the only time this rock was exposed. They had just a bit of time to do it, just that, basically the time of the tide, so about 6 hours. And with using a variety of tools, they excavate out this bone. Unfortunately, they ran out of time, and they actually had to break the bone to excavate it completely, which is what the red line is in here, is that broken part of the bone. But they quickly realized, based on the structure of the bone, that it was a dinosaur. And so they're pretty excited about that. But It was just a dinosaur. There was no information associated with it, in the sense that we really couldn't learn about it because all it was this one little random piece. So it ends up sitting in the Burke Museum. And interestingly enough, it sits there for, I think, several months, if I remember correctly, Liz.
Yeah,
Um,
yeah.
and finally, someone in administration finds out that the Burke has a dinosaur bone, which means Washington State has a dinosaur. They were so overwhelmed, so excited. So they ended up convincing or helping Brandon go figure out what is this bone from? Who was it from? And they helped him by basically giving him money. He travels to a variety of museums carrying his bone with him and eventually ends up figuring out, if I remember, at a museum in Canada, that it was the bone from a tyrannosaurid, not from Tyrannosaurus, because Tyrannosaurus lived 67 million years ago, and this bone is from 85, so quite a bit older. Boners at 78 million. I think I'm off by a few years. Doesn't make 80 million years. But they eventually figure out that it is some sort of tyrannosaurid. And the story ends there from a scientific point of view. And that's where I think Liz and I tried to make things different. We tried to tell a story about that dinosaur that's not just about the dinosaur, because it's a story that's even more interesting, I think, than that, in the sense that this dinosaur is a terrestrial based animal, as I said, and it was found in marine sediments. So, how did it get there? So, we can assume that the dinosaur was living on land, and most likely it died near some sort of waterway, perhaps a river. Maybe it flooded. That body, or maybe just the leg bone, gets washed out into that marine sediment, and then it gets fossilized, and somehow it appears at the surface and is found by Jim and David, and then it's excavated. So that's part one of the story, which is just sort of amazing. The second part of the story that makes it, I think, even further incredible is that that dinosaur and those marine sediments did not form anywhere near here. As I said, plate tectonics, that conveyor belt of plate tectonics, brought those rocks to what is now Washington State. So what probably happened is those animals lived someplace else, to the east, maybe to the south. The dinosaur dies, washes into this marine sediment, and then it gets carried all the way to Washington State and sutured on. So this second level of sort of astounding luck, if you will, or the vagaries of geology come together with this fossil. But I want to go back to the part that's probably more, from a geological or paleontological point of view, more important, is the ammonites that were there, why Jim and David were out there. And just to get at Liz's bias, of course, they're invertebrates, so she's interested in those dinosaurs. Yeah, it's nice,
Yeah.
But these fossils, these ammonites, again, I'm guessing you're aware, they're the animals that often look like cinnamon rolls. These are a classic example, but they're also straight ones out there. With these animals, who are related to squid and octopus and things like that, they provided two key tidbits of information. Liz said at the very beginning, we have lots of radiometric dating. Well, the other way you can date things is if you have a fossil of a known age and you find it in a particular material, in a particular sediment, you know that that is the age of that sediment, or most likely it. So with these fossils, we were able to then figure out the age of that rock, which helped, because if you just had a bone that you thought was a tyrannosaurid, it theoretically could be Tyrannosaurus rex, but because the dating is wrong, we know it can't be that animal. And then the other aspect of having these marine sediments, these marine animals, is we understand better the environment that the dinosaur bone ended up in. So what's to us so wonderful about this, and why we both sort of like to end on this point in terms of our sort of bigger story, is that it combines everything that we were interested in the book. There's a paleontological story, there's a geological story, and it's all overwritten by that human element of a variety of ways that people work together to put together the story of these fossils. So these three, I hope, give you an example of what we were trying to do. These are the profiles or the chapters that Liz mentioned. There are 24 of them in the book, ranging from the youngest, the Quaternary, all the way back to the oldest fossils in Washington, which are some of the trilobites and archaeocyaths. Is that it?
Archaeocyaths, you were right.
Yes, in eastern Washington.
From Cambrian.
So quite old. So that's our story. And what we'd like to do, I guess, is just want to do one thing. I want to go forward one slide and just let you know that we talked to the University of Washington Press. And if you go to the University of Washington Press's website and you wanted to order this book, you could order it and use this discount code. And I will, in the chat, there is a link to the website, and you can get 40% off and free shipping from not just our book, but other books with the UW Press. So I can either leave this slide up for a bit, or I can close it. But either way, we'd like to open this up to questions. If you have them either in person, you'll have to get a mic, or if you want to put them in the chat, we can look at them there. So I can make that work. Oops, I guess I closed that down.
Oh, we can still see it.
Okay.
So I'm here with the mic. Any questions? Go ahead. Oh, there was one of the persons was just wondering if there was other bones or just the singular bone of the dinosaur found.
The only bone that's ever been found there, and people have been collecting fossils from there for a long time. So the water is actually, if you look at the ammonites, the water was pretty deep. It was the edge of the shelf down off the slope. It's a long way for a dinosaur bone to get there. And it is interesting that this is from the biggest bone of a very big dinosaur. And that was the thing that survived that whole trip down the river and way out to the outer shelf.
All right, thank you.
Yeah, we were expecting fossil marine reptiles, but we haven't found any there. They found them in Vancouver, but not on Susha.
I'm not sure how to read the chat.
I haven't. No one's posted a question.
No one's posted. Yeah.
Okay. All right.
I mean, we could talk forever, but.
And in fact, while I'm here, I just want to make a note to Malcolm and Dale. Lemon contacted me about mammoths from Whidbey Island. I just want to tell them I'm working on it. I'm working on it.
And did you say there's a mammoth in Eastern Washington you've been doing work on, or a mastodon, Liz? Or someone?
No, not me. Bax Barton has been working on one out there. Yeah, there's a few big digs out there in the Tri-Cities area. Don't know anything close to Wenatchee.
Okay. Well, I just thank you very so much for giving your talk tonight, Liz and David. And you didn't even have to leave your house, I guess.
I know, it was great.
Yeah. Very interesting. Thank you very much. Appreciate you guys being able to give the talk. And hopefully some of us will take I've written down the address, so I'm going to go on and get a book. So hopefully other people will do it too. So
thank you. Thank you so much.
Okay. All right. Thanks a lot.
Thank you.
All right. Bye-bye.